So this equation is in standard form, and we did this on Wednesday, September 16th. The notes are there. This is just to help guide you through it. Standard form of a quadratic is ax squared plus bx plus c. And the instructions are asking us to write it in graphing form, which is, I don't want to write it on. Underneath, graphing form would be this. Okay, so standard and graphing. And there's more than one way to do this. This is kind of a clever way that the book sets it up. I usually do completing the square, but I actually think this is a better way. So the first thing we did was we took out the common factor of 2. So if I divide each of those by 2, take out that common factor, I'm left with this. And then we said, oh, we could do something with this. We can factor it, right? So if you need to use an area model to factor it, I'll do that super fast. So x squared term and your constant go in opposite corners. And you multiply those to get the top of the diamond. The bottom of the diamond is your x term. So you're looking for factors of negative 15 that sum to positive 2. So that's going to be 5 and 3. And you want it to add up to a positive 2. So let's make that 3 negative. So negative 3x and positive 5x are your missing terms in your area model, which is going to factor into x minus 3 and x plus 5. And you still have this 2. Don't forget about that. That's still part of your equation. So if you're rusty on anything, or you did stuff last year, maybe during remote learning, or you're struggling with anything, let me know. Because I'm starting to get a sense of what you guys did before remote and what you did after. But regardless, let me know if you're needing support with any of that. So your x-intercepts, because you're using zero product property, if these 3 terms being multiplied together, this is a term, this is a term, this is a term. If I'm multiplying them and I'm getting 0, if the product of a equation is 0, then one of these must be 0, or all of them could be 0, or 2 of them could be 0. So if x minus 3 is 0, x equals 3. If x plus 5 is 0, x equals negative 5. So those are my x-intercepts. Trying to match the color with what I did in class. And then I just took those x-intercepts, get this book out the way, and graphed them. And I just did this visually. You could just do it without a graph, I guess. So I graphed negative 5 and positive 3, and I said, okay, the vertex is going to be right in the middle of those two. So if the distance from negative 5 to 3 is 8, then I know that 4 from this direction or 4 from this direction is going to get me to the middle. So 4 from negative 5, 4 over from negative 5, or 4 over to the left from 3 would put me at x equals negative 1. So I know that my vertex is on the line x equals negative 1, and I just need that y coordinate. So I'm going to take negative 1 and substitute it into the original equation. Let's see. So I did of negative 1, which gave me, and I just plugged it into this form right here, 2 times x minus 3 times x plus 5. You could plug it into this form. Doesn't matter what form you plug it into. So if I plug it into the factored form, that gives me negative 4 and positive 4. So negative 4 times positive 4, that's negative 16, times 2 is negative 32. So then my vertex must be at negative 1, negative 32. Okay. And now that you know your vertex, now you can write your equation in vertex form because you know that the stretch factor is 2. So you know you're going to have a 2 in the place of A. So we did that. So we wrote 2y equals 2, and then we used our vertex. We know the vertex is HK. So if that's negative 1, negative 32, then I'm just going to write x minus negative 1, which would be x plus 1, and then minus 32. And then we did check it. We did say, well, how do we know that that's correct? Okay, let's do a little algebra and make sure it's correct. So is 2 times x plus 1, ooh, I forgot to write squared over here. There we go. So it's 2 times x plus 1 squared minus 32. Is that the same as 2x squared plus 4x minus 30? So we did x plus 1 squared, which you can just use an area model for that. X squared, x, 1, so that's going to be x squared plus 2x plus 1. Distribute the 2, so that's 2x squared plus 4x plus 2 minus 32. 2 minus 32 is negative 30, and there we go. So we know for sure we did it correctly. So it's a lot of algebra to get the check, to check and see, but to get the vertex, it's not too bad. Just getting your x-intercepts. So your first step is, if you have a common factor, to factor out that common factor. That was the first thing we did. If your leading coefficient is not 1, I definitely see if you have a common factor. Okay, and then we factored the quadratic expression. We got our x-intercepts, step 3, and then you could just take the average of your x-intercepts. So you could do negative 5 plus 3 divided by 2 to get the x-coordinate of your vertex. Or you could just graph it, visualize it, where's the middle. You could get it that way. I shouldn't say middle, I should say line of symmetry. And then, okay, we substituted, so this was our last step, substitute x coordinate of the vertex into your original equation to find the y coordinate. That's how we got negative 32. Okay, and then we took that and we wrote the equation in vertex or in graphing form. We know the vertex is negative 1, negative 32, so we plugged in a negative 1 for h and a negative 32 for k, and we knew that the stretch factor was 2, from when we started. Okay.